Good day to each and everyone, especially to our instructor, Ma'am Alma Patria. Again, this is your chemist, Princee Mae Mañigos. For today's video presentation, we will tackle all about titration. So, let's proceed. My objectives is to understand more about titration, to know its procedure and types. Do you know what is titration? Is it familiar? Well, titration, which is also known as titrimetry, is a chemical qualitative analysis technique that is used to calculate the concentration of given analyte in a mixture. Titration is an important technique in the field of analytical chemistry and is sometimes referred to as volumetric analysis also. So, we have titration procedure.
Carolina's complete burette assembly contains the basic equipment to get you started, including a burette, ring stand, and a burette clamp. A burette is a long, narrow, graduated tube used to add titrant. It has a stopcock to regulate the flow of liquid. Notice that the markings on the burette go from lowest at the top to highest at the bottom. The ring stand and burette clamp are used to mount and secure your burette. Other materials you will also need include a small funnel to help you fill the burette, a 125 milliliter Erlenmeyer flask, which works best for titrations. The shape of the flask allows for more vigorous swirling than a beaker or other glassware and minimizes spill hazards. A volumetric pipette and pipette bulb to transfer a known volume of analyte to the flask. A wash bottle filled with deionized water, a beaker or flask of titrant and of analyte, indicator selected for your reaction, a reading card to help read the meniscus, and a sheet of white paper to help visualize the endpoint.
The process of titration involves the preparation of a titrant and titrator, which is a standard solution whose volume and concentration are predetermined. This titrant is then made to react with the analyte until some endpoint or equivalence point is reached, at which stage the concentration of the analyte can be determined by measuring the amount of titan consumed. Alternatively, titration is the concept of stoichiometry that is applied to find the unknown concentration of a solution. As for the steps of the procedure, a very precise amount of the analyte is added into the beaker or Erlenmeyer flask. A small amount of indicator is placed underneath a calibrated barrette or chemistry pipetting syringe, which consists of the titrant. Small volumes of the titrant are added to the analyte and the indicator. This will go on until the indicator changes color in reaction to the titrant's saturation threshold. At this point, it will serve that we have come to the endpoint of the titration. Basically, in this case, the amount of titrant balances the amount of analyte present during the reaction. For the preparation techniques, the titrant and the analyte have to be in liquid form. Solvents such as glacial acetic acid or the ethanol are used to dissolve the solids. Concentrated analytes are also diluted to improve accuracy. In most of the non-acid-based titration, a constant pH is required or should be maintained during the reaction. So for chemical analysis, meanwhile, the world of chemical analysis can be divided into two basic types. So first, we have the qualitative analysis, where one finds the composition of a compound. For example, to find the radicals are present in the salt. And we have quantitative analysis, where the interest is laid upon the concentration of an unknown solution. So there are some fundamental requirements that should be understood before one does the titration. The unknown concentration of a solution can be in the form of an acid, base, or salt of an acid or base. For any titration process, the method is similar except for a few differences. The titration process can be divided into the following way, such as gravimetric analysis, volumetric analysis, combustion analysis, and others. Titration can also be used to furnish the purity of samples, calculation regarding pH, and many more. Any calculations during the analysis can be done into two ways. First, we have using mole concepts. So these required balanced chemical equations. Second is we have using equivalent concepts. Balanced chemical equations are not required. Therefore, a sound knowledge of the concept of moles and equivalents is mandatory before studying about titration. In this article, wherever required, the above said concepts are brushed for convenience. So that would be all for my report. Thank you for listening. Bye bye.